All right.
J'ai plus frais tout à l'heure ou non? Parce que la porte est ouverte. Là, ça va.
Well, the quality of the streaming is not very good. We are not experiencing a super Netflix movie here. So this is just to tease is the fake commercial that we pushed on the social networks 1 week ago, and we will probably reuse it for the pack. It's another fake commercial that we're going to use for the pack. So welcome. Here it is. All right, welcome everyone to this webinar. Another webinar series of Neotys with another partner. It's Akamas. So if you've been following us from the pack, virtual pack, and the pack, and also the pack meetup, Moviri and Akamas were very invested. So today we have an official webinar with Akamas. With Stefano, which is also a pack member. So Stefano, welcome on board. Thanks to be here with us.
Thank you, Eric. Hi, everybody. I'm excited to be here today.
So as you can have seen, the theme of today's webinar is about AI-driven optimization, the key to more performance for lower costs. So it's about making a very smart optimization. So if you've been doing tuning in the previous in your career, you will see that Akamas will save that type of task. You don't have to do it anymore. I personally love tuning, but it was something where you started, but you never know where we're going to end. But we're going to talk about it later. All right, without waiting anymore, let's start with the housekeeping rules. So today, as you may know, it's a webinar, which means you don't have access to your mic. You only have the audio. So you're not able to interact with us during this entire webinar, which means you can only, if you have any questions or anything in mind, or if it's something is unclear, there's a dedicated Q&A section in the GoToWebinar tool. So please open it, drop your questions. We will also maybe look at the chat. The chat is not necessarily aimed for that, but if there is no, if there is a missing question, we'll still have a look at the end if anyone has posted anything on the chat. All right, so without waiting, let me introduce Stefano. So Stefano Doni is obsessed with performance optimization. He's the co-founder of Akamas. He's basically driving the vision of smart, or I would say automated performance optimization with the help of AI, of course. He has more than 15 years of experience in the market, and he has been presenting several presentations at CMG, so Computer Measurement Group. This year, by the way, you were there as well in Vegas. And he's been also involved in several packs, so the pack Chamonix, the pack over the top, also the virtual pack. So there have been several presentations where Stefano has been involved. And this year at the pack, we had virtually his colleague Giovanni, who presented also something about smart optimization based on JVM. So it's really great to have you on board, Stefano. And of course, we have also, I will be the co-presenter. So my name is Henrik Rexed. I work from Neotys. I've been working for more than 15 years now in the performance industry. I'm a Lego fan, as you may know. And otherwise, I try to build integrations and solutions or plugins for Neotys. So usually build prototype. All right, let's enough of speaking of ourselves. let's jump into the main topic of today's webinar. So before we start, I think it's really important that I like to usually start by explaining the fact that things has changed a lot, especially in the IT environment, in the way we're delivering. Delivering performance testing 12 years ago in the architecture that was designed 12 years ago and could be hard, but nothing compared to today. I think if 12 years ago, most of our organization were using waterfall, so it's where's 6 distinct steps with going through requirements, design, implementation, testing, acceptance, and deployment. And when it comes to deployment to performance testing, we were usually just before deployment. So we were getting the app. We were usually estimating 2 weeks of work, but instead we had usually a couple of days left because dev shifted a bit, testing has shifted a bit, so we were basically less time to do everything. And also we were trying to optimize if there were some problems, but it was very big challenge because as you may know, most of the ops at that time were taking the default settings of Apache or Tomcat or whatever, putting the app and going there on their environment. So that you could have some surprises there. Then the industry started to introduce the incremental approach. For us, no major changes for performance engineers and performance testers. I think everything started to change from we shifted to agile, so shorter sprints, shorter releases, but we still have the same exact stuff to test, and in fact even more. So how can we deal that? How can we react? So there is a real process and methodology behind the scene to be able to achieve everything and make sure that our apps are performant. The other thing that changed is obviously, I mentioned it, is the architecture. So we used to have a lot of 3-tier architecture with a presentation layer, with a business layer and a database. One of the disadvantage was at that time is that we were mainly deploying on physical or sometimes virtual servers as well. And if you look at the business layer where you have a lot of logic there, you were compiling and building a big binary file, and this binary file were deployed on one node. And if you needed an extra node, you didn't just take the I don't know, client component that was the most commonly used. You had to deploy the entire stack everywhere, so it was a bit heavy. So you don't have you were not really anticipating, you were reacting. Of course, there was capacity planning involved, but still, it was less the notion of elasticity that didn't exist at the time. And now, most of the application that are newly designed are using microservices. I think microservices is pretty a major step in a sense where every service has their own database. You can have their own service code, which means you can have a service A in Java, service C in Go, service D in Python. You don't have to have a standard. And also you can organize and structure the teams. So every team have their own pipeline, and the output of the dev factory, I would say, to staging is a container. So then you can just imagine the right deployment strategy based on different services with elasticity involved. So here we have the ability to deploy more, give more power to one services if one of the services is more heavily used. So it's perfect and really reactive, and it's more modern, and we are more aligned with now the modern way of deploying, especially in the cloud. But this is a really simple deployment example where you have, let's say, very few services, so nothing very complex if you have to envision to test this and to implement this and to deal this in daily basis. But if you look at the market, and here is the is a screenshot of the architecture of Amazon, or in the on the left side, and on the right side you have the architecture of Netflix. So here they are also building their solutions on microservices, but if you have to deal with 100,000 microservices, it looks like a Death Star, and if you start and say you want to implement a performance approach here, I think it's more like a nightmare. You don't know where you're going to start, what is the most important stuff, what should I optimize. So this is a challenge. But there are other challenges, and I think Stefano, you have a lot of things to share as well to our attendees today.
Sure. So actually, I think you summarized pretty well some key aspects that are happening in our world. So how it is changing, that are actually making our job as a performance engineer harder and harder. In my experience, in the last 15 years or so at Moviri, we have lots of organizations actually optimizing performance and cost of several enterprise applications. What we really found is that our job is becoming harder and harder in terms of performance optimization, even with the specs of several years ago. So I think it all comes down to some key changes that are happening in our world, especially in the technology landscape that I think are at the root cause of what we are seeing. So the first one that I wanted to talk about with you today is the configuration explosion. So this is really very interesting because in my opinion, because I think this is being also overlooked even among the experts. What we are seeing in there is that lots of technology, if you think about Java or databases or even the cloud, they are exploding in terms of complexity in one special dimension, which is the number of configurations. So it's pretty surprising to understand that a modern Java virtual machine, for example, has more than 800 JVMs options that you can configure. So every single microservice, every single Java application can have this kind of huge complexity of configuration. And we see also in this during this webinar, which is the kind of impact on performance and cost of the actual application that is being delivered by changing this kind of configurations. But this is not just Java specific. We have lots of layers in the stack that are following the similar trends. Databases, it's actually pretty much the same. You can see here MySQL, Postgres has a similar kind of trend with 500 kind of settings, but also the cloud. So the cloud provider are adding more and more kind of options in the cloud, which strictly speaking are not configuration options. But if you think about, for example, the compute service of AWS just added more than 100 new kind of instance types just in last year. So this is a huge complexity that is happening in our space, which I think it's deeply impacting also our effectiveness as a performance engineer to being able to deliver faster and cheaper services. The other kind of trend, which is, I find it very, very interesting from a performance engineering perspective, is that this kind of configuration setting often have unpredictable effects. So what does it mean is that if you think of a database, so in this example, we are thinking about measuring the impact of a pretty wide-known performance related parameter of database, which is the amount of memory we assign to the database. I guess many of you would be surprised to understand, to figure out that, for example, if we add more memory to a database, the database may actually slow down. And even more surprisingly is that sometimes if we remove the memory, we assign less resources to the database may actually run faster. So this is, I think, very, very interesting to recognize that this kind of evidence, because we collected several of them. And I think it's important from a performance perspective because they are, in a way, highlighting us the importance of configuration setting, but at the same time, they are reminding us that our system more and more can behave in a counterintuitive ways. So even the following vendor best practices, like we have all done for decades, is not enough to guarantee that we have the cheapest system, the highest performance system possible. The other trend that is actually in line to what you mentioned so far, Eric, is of course the DevOps trend. it's another big shift that is happening, more related to the way that software gets built with respect to the technology landscape and how it is changing. So actually, releases of new software are being pushed to production faster and faster. This is impacting, of course, our work in two ways, basically. So we have less and less time to do performance optimization work. So most of those kind of things that we will be talking today, many organizations simply don't do them due to a lack of time. And the other thing is that even if we spend time looking at those configuration options, and we think of even spending weeks because we think it's an important release, we need to optimize it, we need to actually be very precise about the configuration to make sure that the system will perform at its best. So this optimal configuration that will be found manually will be simply outdated, I would say, the next week, because actually a new release will come out of the pipeline of our newer software development cycles, and simply what the whole work that we have done manually will be simply useless. So we need to restart from scratch every time. So those are actually very, very important problems, but related to the configuration space. But I think one of the key questions that we get often asked is, okay, that's nice, but what is the real impact of actually optimizing the configuration? So are we talking about improving performance by 5%, 50%, 5x? So what is the kind of order of magnitude of performance improvement that we can achieve, performance or cost improvement? So I like to bring up this kind of example because actually we presented also at several conferences. It's related to the performance optimization work that we have done for one of the major insurance companies in Europe. And you can see actually the kind of, this was a pretty standard application server technology stack. So you can see that we were able to cut the CPU utilization of this server by 75%. So it's a pretty huge kind of impact, and we didn't touch application code, so we didn't need to call in the developers and optimize the algorithm or the queries. We didn't actually buy faster CPUs or buy additional hardware, which is actually a pretty common way to react to this kind of performance problem when application meets their SLAs or SLOs. The only thing that we did was actually better reconfiguring JVM options. So again, a Java kind of application server that pretty well highlights the kind of magnitude of the improvement that we can get. So to summarize, from a business perspective, we are seeing actually lots of effects. So it's not just the first one that you see mentioned is the one that we just talked about. So we are spending more and more on infrastructure and on licenses, where we are in a situation where software is licensed based on infrastructure usage or number of cores, for example, which is the obvious, in a way, side effect of running today's system with default or poor configurations. But there's the other one, which is also related to performance, as we all know very well. There are always two sides of the coin. So performance, customer experience is also highly impacted because oftentimes our application run with simply wrong configuration settings that may be actually outdated, maybe the default, which are not necessarily working well for our kind of work and our kind of application. So this is highly impacting also the end-to-end performance. And we are going to see exactly which is the impact on our demo later in the webinar. The other two are actually related to operational agility. So again, to the time to release. So if we do this kind of work manually, we are going to impact pretty significantly the time that we need to ship new releases. So we regularly see times like even 2 months for task force type of work, where several engineers also with the help of the vendor sometimes actually are put together in task forces to actually address this kind of optimization initiatives. But most of the cases, the real problem is that those kind of processes are today actually pretty a trial and error process. So they are manually, so you change one thing at a time. They are slow, and actually also you are not really guaranteed about the effect that you are achieving. So you are doing an activity that it's actually also are very hard to do for the human brain because of the complexity that we have talked about. So one of the typical ways to actually solve the problem, we always use actually it's load testing. So we always use load testing for actually getting an handle on understanding how much load an application can support, what is the best configuration. So I guess we might start with a refresher with a performance testing approach. So Harry, would you like to describe it?
Of course. So here is the standard flow when it comes to load testing. So this flow, you can still find it in shorter cycles, but it's going to be the same step that you will have the same approach. First, you need to have a strategy. So what do we mean by a strategy? Load testing is only about simulation. So if you do the wrong simulation, then you will collect numbers related to that wrong simulation. So keep in mind that everything is about a simulation. So if you do the wrong simulation, your test won't reflect real life, and you won't be able to take the right decision. So building strategy means which use case I need to select to make a representative load, what will be the workload I should apply, what will be the think time, the pacing, what type of data sets, all that type of things. Then also we can also figure out what are the key indicators, what should I monitor, what are the really important stuff, what are the tasks that I need to achieve to make my load testing possible. Then you move on to the second step, which is I need to record, or I can still design manually my use cases in the load testing product, but most of the time if you interact with the UI, with a mobile device, it makes more sense to record for sure. So building test scripts is not about record and playback. It doesn't make sense. You need to correlate. You need to import randomizations. Otherwise, if you don't, you will only hit the cache. So it's cool to hit the cache, but if you just hit the cache of the database, or if you only hit the cache of the web servers, then you're not stressing realistically the different components of your architecture. So make sure that you have enough data sets and you have enough randomizations in your scenarios. Then we're going to prepare. So you need to have a load testing infrastructure that is well sized, that the statistics of the index of your database is well calculated, that you also have the right extractions. You have to set up the monitoring. Monitoring. Sometimes people say, I'm going to run load tests without monitoring because monitoring is so complex to set up. Yeah, it's true, but if you don't set up the monitoring, it's going to be similar to listening to a horror movie in the radio. So you will hear a lot of people screaming, but you don't know why they are screaming because you don't have the clear picture. So monitoring will give you the picture, the sound, and you will understand what's going on in that movie. Then you're going to execute the different tests that you have decided. You will analyze, figure out if the test makes sense or not. And if there is a major problem, you could figure out if you can do some improvements just by tuning without touching the code, like Stefano explained. Maybe just changing a few parameters on JVM, maybe we will have better improvement. If not, sometimes if you cannot optimize, maybe there is a big problem in the design, in the code of the app, so maybe you have to go back and ask gently to the developers to change the code. I'm not able to, okay, here it is. But like I said, this is a reminder. If you are giving a project to someone new in the performance world, the first thing that person will do is generate hit per seconds. If you give it to a developer, the first thing he's do is say, hey, I'm going to explode the hits. It's pretty cool. It reminds me of Street Fighter, where you have that bonus stage, where with the Street Fighter is the video games, where you have two fighters and you have to win in 3 rounds. And sometimes you had that bonus stage you didn't control very well when that stage will happen in the game, but the concept of the bonus stage was simple. There was that car, finalized car, brandy and shiny, so that's similar to the app. So we were testing in the 12 years ago. We were waiting to get that car assembled, so that application assembled, and then we were generating our test. And those who were new in the performance world, the first thing they were doing, they will exactly doing the same thing that a fighter, they will try to break the car. And that was pretty fun. So people were looking at the numbers, say, hey, I'm doing a huge number of hits. It's pretty cool. But again, you break the car, you're proud of it, but what's the purpose? What do you prove? What do you collect? Are you sure that your app is going to react properly in production by just breaking it? Not sure. So performance testing, like I said, is everything about simulation. So the first thing that you need to do is to understand your app, understand how your user is interacting with your application. At what time? How is the workload happening? How is this user connecting in the morning? How are they disconnecting? Where are the spikes? All those informations are really, really important because we want to reflect as much as possible the real production activity. Not real, but we will focus on the 20% of traffic that represent 80% of the load in your production environment. And you have to understand that there's plenty of way of doing it. You can collect that through tracking systems, Google Analytics or Adobe. There's APM products that give you also a lot of insights. There's logs, so there's plenty of way of doing it. Remember, if you don't do that, your test doesn't reflect. And also, one thing important, if you do it once and then you say, okay, I'm going to keep that workload model until the next 6 years, then maybe it's good for the first year, but maybe the second year your tests are not relevant anymore. So you have to have this DevOps infinite loop where every time you try to extract and figure out if your testing strategy is always aligned with your users. Okay. So now with this agile approach, we are not going to test only from the UI anymore, because if you do that, maybe you may discover problems, but they are too late and too expensive to resolve. So that's why we're going to test earlier, test as much as possible, testing at the component level in dev environment, doing the same type of tests on and on, because you're fishing for regressions. If you do the same load at every time you build your app, you can detect any regression between two build or two commits from a developer. And then we're going to do the integration testing. So integration testing, you take the several components that has been promoted for staging, for example, you're going to deploy and and connect them together. By doing that, usually you start introducing latency between the several nodes. So here you can have also a lot of performance problems. And last, this is the traditional way of doing performance. User experience is important, so don't underestimate that task anymore. There are still major release that requires this end-to-end testing like we used to do a few years back. So I mentioned, if there is a major problem, we usually are doing tuning, manual tuning. So first thing is you have to consider that nobody is touching the config files. Usually the config files of the architecture are the default one that was provided by the vendor, or the open source community, whatever. But so sometimes by just touching few config files, you can improve in a very good way the behavior and the performance of your application. So the approach were very simple. So you here on the right side, you have an example with a Apache web server. We have 3 Tomcat nodes, and in the back end we have a Mongo database. Every of those, and of course, all of those nodes are running under containers and running on Linux operating systems. So in all of those layers, the kernel of Linux, the container, the Apache, the Tomcat, the Mongo, there are specific config files where you can improve slightly the performance. So if you want to tune that, first thing you're going to first, you have to get a baseline. So you're going to run a baseline to understand how the system reacts to the load, adapt the load to have a normal condition. Then on each of those layers that I described, there are those different parameters on the kernel or Tomcat or Apache or whatever you identify a few parameters where you're gonna basically wants to change to increase the performance. So when you were doing manual tuning, the first rule that we had is only change one single parameter at a time. Otherwise, you don't understand if you start to do two parameters change. If change two parameters, then you don't know if it's due the results that you get out of your test are due to one of the parameter or this other one. So you change one parameter, you run your test, the same test as the baseline. You analyze to figure out, did I have improvement or not? Yes, I did. So then if you have improved with one parameter, then you can go to the next one. And you were doing this. Basically, you were spending hours doing that. But it was, for those who likes technical stuff, it was passionate. It was great. And Stefano, what are the other things that you have to consider when you do manual testing? What are the problems?
Yeah, sure. So I think as a performance engineers in the industry, I think we all realize that the state of the approach that we describe is largely not well solved as a job that we need to do. So actually we see lots of problems there. So for sure, the first one is that it's manual. So we are wasting lots of weeks and months in task forces and doing these kind of optimization initiatives that are mostly actually guesswork, because actually due to the complexity and the kind of counterintuitive effects that we talked about at the beginning, we cannot really predict what will be the effect. So there's no other way to the trial and error. And by the way, it's also error prone because actually you have to change lots of stuff that is not tracked anywhere. So it's very easy to miss the smallest detail that can significantly impact the whole actually work that you are doing. The second piece, which again is tied back to the complexity of the system that is increasing, is that you need to be also expert on the different technology layers. So this kind of optimization, if we are considering that each layer has hundreds of tunables, so you need to know what are the key ones, what to touch, what are the values that make sense, and actually this is something that you can already afford. So it's not something that it's feasible today, where we have smaller and smaller product teams that take care of a product end-to-end from development to the operation, to have this kind of expertise. But by the way, it's also something that cannot be really done due to the complexity, due to the amount of combination, millions of combinations, if you think about the dimension of the parameters. So even we find often that vendors themselves cannot really optimize anymore their own technologies due to this kind of complexity. The other point is that the end criteria is difficult to define. What does it mean is that as this kind of trial and error process is trial and error, so you cannot really anticipate what will be the residual kind of amount of value that you can still extract out of this process. So you simply can allocate some amount of time and hope that in 1 month or 2 month time you will be extracting the most performance, but you might discover that many times we discover that lots of weeks are spent by extracting any more additional relevant performance gains. So it's hard to understand when to stop. And the last point is actually pretty important, I guess. I don't think we talk about it very significantly as much as it deserves, which is the topic of variability. So we oftentimes due to the cloud, the container, the performance isolation among the new technologies is not that great. So this means that we need to repeat our performance test several times in order to actually trust the results. So this is another kind of complexity that ties back to the fact that we need to do lots of tests, but also once we have identified a good test, there may be a situation where we simply execute again the same performance test and we get completely different results, also due to the underlying variability that we have in some systems. So this is another kind of challenge that we have to deal with. So when actually, I think we summarized pretty much the state of the industry in terms of the new kind of trends that are impacting why our world is changing in terms of the way software gets built, and also in terms of the way the technology landscape it's changing. So I really think those are among the biggest root causes, the biggest reason why we as a performance engineers in our profession may not be really that effective anymore with this kind of manual performance optimization process. So the risk we have today, and we often see it ourselves when doing manual stuff, is that we leave significant performance and cost optimization potential on the table, because actually we cannot really be smart on this kind of manual tuning approach. So when we started out thinking about the new approach, actually, when we experience this more and more this kind of evidence in our years of experience, and we actually started thinking, what would be the next step? What would be the new game? So what would be the new way to actually reach this kind of benefits without this, in a way, painful process that we have today? So in our view, actually, the next step would be actually to have some kind of smart system that can actually help us automate all this kind of work, because it's tedious work where actually, if you think about the brain value of an expert performance engineer is not well used, because actually it's too complex. It's a sort of mathematical game to come up with the best configuration. So there's no really human level inside that we can use for this kind of task. And so we spend also lots and lots of time actually doing manual activities where there's no really value. And on the other side, actually, the complexity is exploding. So the human brain cannot really understand the interplay and the intricate configuration settings that we have in the technology. So in our view, there should be actually smart system which can help the performance engineer actually on one side to automate all the tedious activities, and on the other side actually help us extract the most performance and the cost advantages from our system without having us to deal with those kind of complexity where our human brain is really not suited. So this is exactly the goal that we had in mind when we designed Akamas. So if you build a new actually smart system that can help performance engineers, we will use, as we are going to see, we use AI as a way to actually come up with best configuration and explore this huge configuration space of billions of configurations options that are possible with today's technology, and still be fast. And because we automate lots of activities that today's performance engineer have to do manually. But before diving into the product, I want to just to showcase you an example, which is a real customer example where we applied Akamas. So this customer was a large financial institution, and their goal was to extract the most transaction per second out of their payment application. So this was one of the largest financial operators in Europe. Their goal was actually to improve the payments per second that could be extracted within a given application and infrastructure footprint. So the customer didn't want to spend more also on the licenses. So the customer already underwent a 3 months period of manual tuning kind of process, which, by the way, we're done applying best practices like we all do, and the kind of maximum throughput that they were able to achieve was 220 payments per second. So this was the most important business KPI for this payment platform. So we actually integrated Akamas and let Akamas actually change the configuration of basically the entire stack. So we tuned the application, the middleware, and the OS. It's interesting. It's very interesting to understand, to see actually what Akamas actually achieved. So on this chart, you see the baseline. The first experiment, the red dot, is actually the baseline. So the initial configuration, which was already the end tuned by the experts and the vendors, 220 payments. And you can see all the other gray dots are also the performance that Akamas was able to achieve by changing the parameters of the stack. So you can see that initially Akamas need to explore the system and understand how it reacts, how all the different parameters actually are relating to the final KPI that we want to maximize, which is the payments per second. But soon after the initial, in a way, learning period, Akamas was very, very quick to understand what was the best configuration for the system. You can see that points start trending up, meaning that Akamas is actually understanding what are the best region of this hugely complex optimization space that is giving us higher and higher payments per second. And you can see that after a while, actually, we were able to reach 55% more payments per second out of the same system. So this result pretty much shocked the customer, because actually after 3 months work, even with the vendor, they thought that they actually reached a top performance for this kind of system. But in a way, this testifies the actual amount of performance improvement that is lying basically unexploited today in our system. The other interesting fact that I wanted to highlight is that the process was actually completely automated. So actually, we integrate in this case Akamas in their load testing environments. We will be going to see the demo in exactly the same, in a very similar setting, of course, with the integration of NeoLoad, we shall see in a couple of minutes. And every dot that you can see here is a performance test that was driven by Akamas, and each dot had a different configuration setting. You can see that in a pretty less than 1 day, actually, the system was able to achieve a pretty significant improvement in terms of performance that wasn't reached by actually the most expert developers and also the vendors on this kind of system. So in order to reach this kind of a system like Akamas, there are major innovations that needed to be introduced. So we did lots of development and research work also, by the way, with the help of our relationship with Polytechnic of Milan, which is one of the leading universities in Europe. So the first actually major pillar is that Akamas is based by AI. So we use AI contrary to other tools that start using AI in the performance optimization space, like for example, APN tools. Akamas AI is pretty different. So we use AI not just to suggest what happened in the past, but we use our AI is actually selecting the parameters, the best configuration in the huge parameter space, and it's actually automating also the application, the setting of the parameters into the stack. So our AI is not just giving suggestion to the users, but it's actually applying the parameter to the system in order to automate the full process. Second step is automation. So we have seen that today in the performance tuning process, it's trial and error, it's manual. So we have lots and lots of activity that are being carried out manually, basically. So we think that this can be actually improved. It's a situation where we have lots of activities like, I don't know, watching the performance test results that can be greatly automated. So our automation is actually, it's an end-to-end automation where we define, and we are going to see exactly this, how it works in the demo. So we automate pretty much the whole performance optimization process, including the setting up the environments, launching the performance test thanks to the NeoLoad integration, and also analyzing the load test results and understanding the configuration to apply. All of these can get automated, and you can start actually enjoying these kind of benefits. The third point, which is actually pretty important, is that the Akamas is goal-driven. What does it mean is that, as we have seen in a previous example, the customer goal was to improve payments per second. So it was a business level metric. It was not a technical metric. So we didn't talk about decreasing CPU or increasing the throughput of a Tomcat application server. So with Akamas, you can specify basically the goal, which can be your own metric that you gather from your monitoring tool. And very often customers select a business relevant metrics that they want to maximize the throughput, or they want to minimize latency of a user facing business critical service. This is the kind of, with Akamas, you have this kind of capability to define exactly what the AI should work for. The fourth point is full stack. So we have done lots of examples about databases, Linux, and also JVM. But with Akamas, we design a platform that is an end-to-end optimization platform powered by AI. We can really address pretty much any technology. So the way that we built our machine learning, it's pretty agnostic with respect to the technology. But at the same time, we provide a library of what we call optimization packs, which are actually a library of sort of plugins within the platform that allows you to readily optimize market-leading technologies without having also to know the details about which parameters are actually the most important ones. So we have already done this kind of work for you. So I want to just actually introduce you at a high level how does Akamas work. So we have in this chart, we have Akamas on the left and the system to be optimized on the right. System to be optimized can be pretty much anything, can be a three-tier architecture that we talked about before with Henrik, so a couple of years ago. It might be a microservice, it might be a database, it might be even the whole full stack of a particular application. So the first actually phase is the configuration. So we talk about the fact that Akamas needs to actually apply the parameters. So it's automating also the application of the setting of the parameters to the system. So it's not just a system that suggests us what to do. So it's also automating this part. So in order to do that, we have a workflow engine within Akamas that lets you automate also the setting of the parameters. And here we can actually interact with several kind of system, like for example, configuration management system like Ansible that you may already have. We can integrate within pipelines, for example. We can even simply go change the configuration files on a remote machine via SSH. Any kind of approach will work for us. The second step, once the Akamas configure the system, is to drive the experiment. So experiment for Akamas, what does it mean? This is actually the way that Akamas can actually understand if a given configuration was good or not. So typical way, as we talked about earlier, is to do performance tests in performance testing environment. So in that way, so the key design decision with Akamas was, let's not reinvent the wheel. Let's simply integrate with existing load testing tool on the market. So you can see a couple of options. And of course, the NeoLoad integration comes into play, as we are going to see in a couple of minutes. So once we have actually integrated Akamas with load testing tools, the first step will be actually to gather the metrics. So of course, the AI needs to understand how the application is performing and needs to understand if we are improving the goal or we are making it worse. In order to do that, again, the design choice was let's not have an agent. So again, Akamas' choice is to integrate with existing monitoring tools. We call them telemetry tools. And again, we recently launched also the Dynatrace integration, so we can gather metrics from APN tools regarding the full stack that Dynatrace is able to monitor. And of course, this is again where the NeoLoad integration comes into play, because we can bring in load testing metrics like throughput, transaction throughput, transaction response time, transaction errors, and so on, which is very valuable for the optimization point of view. The fourth and last phase is the AI optimization. So once the Akamas configure the system, it launches an experiment, and it measures the goal, actually the next step will be for the AI to actually decide what would be the next configuration. So this kind of four-stage process is actually a cycle, a true optimization cycle. We actually close the loop, because actually we can optimize the performance end-to-end, the performance of an application, considering end-to-end response time, for example. And basically the whole cycle repeats until some kind of exit condition is met. Like, I don't know, how much time, the number of experiments that you have chosen, or a kind of time frame that you allow for the optimization. So that was it at the high level. So let's now see very quickly how the actual integration works, and then we will move on to the demo.
I was muted, sorry. So the first step, which is the most important, is to define objective. So I want to have response times under that amount of milliseconds, for example. I want to have a CPU usage of. So you have to define what your expectations. Then you have to specify in Akamas what are the parameters that you are going to touch. If you want to touch on the kernel, the containers, the JVM, so there is lots of various parameters. You will have to precise the list of those. Then obviously Akamas is going to run simulation, so load test. You need to have a load test project prepared, so you will connect Akamas to an existing project that is defined in our SaaS or in your on-prem environment. And then what we're going to do is, for each simulation is going to be the same one. So Akamas is going to deploy the app. with the right settings that has been defined for the simulation. Akamas is going to launch the test. So NeoLoad will start and run the test. And while the test is running, Akamas is going to collect the metrics from the various data source. So NeoLoad become a data source for Akamas. Dynatrace, Prometheus, and the others will be also. And then once you receive back the various metrics, Akamas will make the magic to figure out if it has to change one or other parameters. All right, so let's jump to the demo. Here we have chosen a Java app with a MySQL database. So what are the objectives that we have defined here?
Yeah, for the business objective for this kind of demo project will be actually to reduce the cost of this e-commerce enterprise platform. So the technology stack is Java-based, so it's basically a Docker microservice which manages the core logic of the e-commerce platform. So as regard the goal, so as Eric mentioned, the first thing that we need to define within Akamas is what is the goal. So AI is working for us actually to automate our tasks toward a specific goal that we can define as a performance engineers. So in our case was to minimize the infrastructure usage, in particular the memory, which is oftentimes a bottleneck in container environment, especially for Java applications. But of course, we also wanted to preserve application performance and error rates. So we certainly doesn't want to actually make the application run slower in order to save cost. So as regard the optimization scope, so what Akamas is really optimizing, so we chose two kind of layers which are pretty typical in a microservice environment. So on one side, we have the Docker container resources, so the amount of CPU and memory that you actually are asking to your container orchestration platform like Kubernetes or Docker to assign to your microservice, and also the Java virtual machine options, which are pretty, in a way, a long-standing problem to extract most performance from Java application is how to properly optimize heap and garbage collection and all the dynamics related to memory management. So we chose, this is a typical target for us, so we chose those two layers because they have also interesting interplay among them.
So the demo environment is very simple. So we have a Amazon instance that we have spin up. We have deploy on that Linux instance, with Ubuntu, in fact, contain Docker, and we are running a Docker Compose to deploy the app. It's going to be, the demo app is Konakart, which has described the Java plus micro database. Side of that, Akamas will be also running in the Akamas environment. NeoLoad Web will be the NeoLoad Web SaaS, and we will utilize some control and containers that Akamas will control. All right, so that will be a great introduction for me for NeoLoad Web. For those who's not familiar with NeoLoad Web, NeoLoad Web would be controlled by Akamas completely. Start, collect data, and so on. So NeoLoad Web is the new flavor of NeoLoad, where you have a central component in the middle that orchestrates controllers and traditional controllers and load emitters. So you can still do the design with your natural GUI client that you used to use a couple of years back, and you can still run that from the controller and connect it to NeoLoad Web, or you can delegate everything from NeoLoad Web, where you can import a project, and NeoLoad Web will select which controller he will use, which load emitter you can use. You can take advantage of the dynamic infrastructure feature, where NeoLoad will, if it's connected to a Kubernetes cluster, he will spin up the right infrastructure for the test and turn them down. The great thing with NeoLoad Web, and that allow us to make this integration possible with Akamas, is the API. We have almost one API for everything, for starting, stopping, getting data. You can control everything, so you don't have to wait until the end of the test anymore to get a result. If you want to stream out the data lively, like Akamas is doing, you can do it with our API. All right, so let's jump into the demo.
Sure. Let me switch to the web UI.
Yep, so this is the UI of NeoLoad Web, for those who are not familiar. Just briefly, I'm going to go through several things. So first, we have this notion of resources. So resources is where you will define zone. So zone is basically a way of structuring up your load testing infrastructure. If you're a fresh new NeoLoad web, you will only have a default zone, and then you can create several zones. So it could be static, where you will register controllers and load generators, either through traditional installations that you may have used in the past, or containers. Or it could be dynamic. Dynamic means NeoLoad will reach out to your Kubernetes or OpenShift cluster and speed up the environment. Of course, you need a license because here the testing capacity utilize a license that is enabled and activated in your SaaS account. So here we have a license available that allow us to do the test. Home is where you're going to see the various test simulations. You can see that Akamas has already run several tests. So we'll let Stefano describe them. And test is where you define your test. So either you can create manually, or you can create a new test. A test is a combination of a project plus a scenario, and then you define which zone you would like to interact with. Zone in a sense of NeoLoad, controller load generators. And then you can run that test either from our UI or from API. And by the way, we have released on the 7.4 Python client that can interact and control all the things that I just mentioned about it. So I think now you have a fresh new background on NeoLoad web. I'll let you, Stefano, go further on the Akamas side.
Sure. So we start with the actual introduction, a little bit introduction with Akamas. So actually, Akamas is a platform for allowing multiple teams to actually optimize performance of their system. So I currently logged in our demo environments, where I have the study of related to the demo, the Konacar performance optimization that we talked about earlier. So for Akamas, a study is a concept of kind of optimization initiative. So is how a performance engineer define the kind of application that you want to optimize, the kind of parameters, and of course the kind of goal that you want to achieve. So let's click on a study which is related to the Konacar e-commerce platform that we are going to see today. So when I click on a study, again, I'm presented with a couple of summary information here in the summary tab. Most important one that I wanted to actually make you aware of is that it's the goal. As you may recall that Akamas is a goal-driven optimization, and you can really see how this play out. So in this case, we are asking Akamas to minimize the container memory limit, which is one of the key metrics related to the performance, the footprint of the memory of container environments. You may recall that that was the goal of our exercise. And by the way, with Akamas, we can also express additional properties, because in reality, when you do performance testing exercises, you often have sort of performance constraints. So in this case, we want to shrink in a way. You want to make the application cost less, be cheaper, but for sure we don't want the application to be slower, or we don't want the application to start actually returning errors to the users. So you can see that we support this kind of declarative goals for the performance engineers to let then AI and the automation actually understand how to best configure the system. So in this case, I specified the constraints related to the transaction response time. And those, by the way, are the metrics coming from the NeoLoad load generators that should be lower than a given threshold. And also the same applies for the error rate. You can then see what is the optimization scope that we selected here. So in this case, we are optimizing a sample of 8 parameters. So it's already a multi-level optimization, meaning that we optimize 2 parameters related to Docker containers and 6 parameters related to the JVM. So in order to optimize this demo application, we choose to actually execute. You can see a summary of the experiment. So you might recall experiment is a different actually performance test that gets executed by Akamas, in this case integrating with NeoLoad, as we are going to see. So if we go to the progress tab, I can see actually all the experiment that gets executed by Akamas completely automatically. So for each experiment, I can see the score. So what is the value that it is getting with respect to the goal that we have defined. So in this case, it was reducing the memory footprint. So this is an indication of the amount of memory that the application consumed in this particular experiment. And for each experiment, I can quickly show actually what is the configuration that Akamas AI choose for this experiment. So you can see that for every component that we have in our application, we have all the parameters that are already mapped within Akamas in order to let you not be expert of every specific technology. So this relates to the skill shortage problem that we talked about earlier. And for each parameter, you can see actually the actual values that were specified by our AI. And you can also see what were the baseline values. So those were the starting point that may be suggested, for example, by the vendors or by expert tuning approach. So each experiment is actually carried out completely automatically by Akamas. This is done through a concept of workflow that we have within the platform. So workflow allow performance engineers actually to get rid of all the manual and tedious activities that are required to execute a well-done performance test from end to end, I would say. So we have operators within the platform that allows you to, for example, execute remote commands to stop the application, or operator that allows you to configure the parameters in a configurator in a configuration file, for example. And the last step that we usually have, of course, in a workflow would be once you have set up everything, once you have configured your application, what you're going to do is to launch a load test. So this is where the native integration with NeoLoad Web comes into play. You can see that we have built a specific operator for NeoLoad Web, and you can see here just the required. What are the required parameters that is needed to actually allow Akamas to invoke performance test done by NeoLoad? So actually, we just barely need we simply need the account token for accessing, of course, the NeoLoad environments, and also the scenario name. Scenario is actually it's actually telling NeoLoad which kind of load test to execute. Once we have done this kind of definition, which is, by the way, very reusable across many applications, so it's actually very helpful for performance engineers. If we jump back to the NeoLoad, we can see actually all the tests that get executed completely automatically by Akamas. So you can see, those are all the tests that are driven by Akamas. You can see we have the name of the study, so minimize memory footprint of a Java microservice was our Akamas study, and we also have an indication of the experiment ID that we can match with it from the Akamas side. And if I click on a specific experiment, I can see that NeoLoad provides me all the performance and error rates, response time metrics that are related to the performance test. So you can see, for example, number of users, the errors, the response time, and the throughput that actually the NeoLoad recorded during the performance test. So far we have seen that Akamas can completely drive NeoLoad and actually making the performance optimization process automated. We also have another direction of the integration, meaning that all the performance metrics that you see here, we also integrate them within Akamas. We have done that because we know that performance engineers love to actually do analysis on the metrics and understand what is happening on the system. So if we go to the metrics tab within Akamas, we can actually have an overview of all the metrics that we are bringing in. So in this case, those are metrics related to NeoLoad. So for example, I can choose to chart the response time and the transaction throughput. So you can see that now I can see over time exactly the metrics that I have selected, transaction and response time. And by the way, Akamas is already automatically presenting me the results related to the baseline configuration, which is the orange one, in this case for the response time, and the green one from the throughput. And it's also already comparing me the best configuration. So the best, this time series is actually showing me the response time of the best configuration that Akamas was able to achieve. So I can instantly compare how the best configuration performed against the baseline. So in this case, as regard the throughput, I can see they are pretty much the same, which is a good news because we are optimizing the footprint. So the application is now consuming less resources. and it still actually have the same throughput, which is actually good. But also it's interesting to see what is happening to the response time. So if we compare the response time of the baseline and with respect to the tuned, we can see that actually the tuned configuration is actually having even a lower response time. So we managed to actually reduce the footprint, and at the same time, we managed to make the application run faster. Third point that I want to show you is actually the results. So what are we getting out of the optimization? So under analysis, I can keep track of the progress of the optimization. So this chart is pretty much the same chart that we have shown before. So each dot is a different performance experiment where Akamas actually changed all the parameters, and you can see how quickly Akamas understand how to minimize in this case the footprint of the application. So this chart is showing me the amount of memory of the container in this case with respect to the baseline configuration. You can see that in a very short time frame, we are speaking about pretty much 20 experiments. We was able already to decrease the amount of memory by almost 40%. The other thing that I want to show you is that under analysis, we also gather lots of performance metrics related to not only to the performance test, but also to API metrics or infrastructure metrics. And I can, in this table, I have for each row of this table is basically a different performance experiment. So again, it's a different dot on the previous chart. And I can quickly compare, for example, what is happening to the container memory usage. I can, for example, quickly compare to what is happening to the response time of my transaction. So for example, I can quickly see that the configuration that provided the best reduction in terms of the goal also had actually pretty much, we also cut in half the response time with respect to the baseline. So I can see here the response time of this particular experiment and here the response time of the baseline. So I can quickly slice and dice using this kind of analysis approach. And we build this kind of capability for the performance engineer to actually understand what is happening. Last point is going back to the summary. The summary actually provided us also the best score. So what is the best configuration that Akamas was able to achieve in terms of the score? So again, this was a goal related to memory usage. In this case, we pretty much went from 3 gig, which was the baseline, to 1.7 gig, so a 43% reduction. This also may be payments per second or whatever you want to optimize. And also the other thing is that Akamas is showing us the best configuration here. So what this means is that for each parameter that we have selected is presenting us the best value, which we can quickly compare to the baseline, so we can quickly assess what Akamas did. But most importantly, we built in also a feature that allow the performance engineer to understand what is happening, so to understand how Akamas was able to achieve this kind of results. So you can see here the relevance is helping the performance engineer to understand which of the parameters are actually most impactful on the goal that we have defined, and this comes straight out of our AI engine for these kind of purposes. So I guess that is it.
Yeah, I think just go to the takeaways and then we jump to the Q&A because we are already a bit late to be looking at the time.
Sure. Sorry.
Put it on full screen, maybe. Yep.
Okay.
All right. So just to summarize, we told that the IT world is changing a lot. The complexity comes along with it. So tuning manually now systems that are lots of layers becomes almost impossible. So you need to be smart. I think Akamas is the best best solution that is on the market, and only solution, as I know, maybe that could allow you to do that. Stefano, where will be your wrap up?
Yeah, sure. So actually, I think we show pretty much what is the kind of benefit that you can gather by integrating the two tools. So you have the power of NeoLoad in being able to actually generate realistic load and integrate within your CI and all the benefits that you have. And with this native integration, it's actually becoming very easy to add on top Akamas AI engine to actually automate all the performance tuning work, and also saving time, but also extracting the kind of benefit that we have seen, which typically would have required months of manual work. And just to conclude with some data points that we have seen, and we are getting lots of those in actual projects. So we are able to reduce, in this case of a Java application and Docker, it's a typical use case for us where we're able to reduce the footprint of this new kind of microservice technology, which is is becoming very, very popular. One of the challenges for them is how to actually we reduce the cost while still preserving performance. So with this kind of approach, we are able to, at the same time, actually reduce the infrastructure and also cut pretty significantly the response time, which are actually two goals that are typically very, very hard to achieve with a kind of manual approach.
All right. One thing I'd like to also mention, if you want to learn more, we have the Akamas datasheet, NeoLoad Akamas datasheet that has been online just before the webinar. So if you want to learn more, you can download this datasheet from our resources. That will showcase the usage of NeoLoad, Dynatrace, and Akamas. So if you want to learn more, please have a look at that. Otherwise, if you want to have more details, don't hesitate to go to our both websites, akamas.io when it comes to Akamas, and neotys.com if it's more related to Neotys. All right, let's jump into the Q&A. There are a couple of questions up. So there's the questions, but here I think it's quite obvious. Can we use this on a production system based on a real usage pattern? It can recommend the config parameters. I will let Stefano answer, but I would say no, because Akamas requires to deploy and restart the environment. So if you want to have an unstable production environment, then
but there are actually strategies to actually apply in production, because actually in a newer system, you can a containerized system, for example, you can have strategies like canary deployment, where you can actually select a small part of your infrastructure to be used as a way to tune the application and not impact the overall user experience. So there are strategies, and there are also technology layers which allow configuration settings without restart. This is the case, for example, of many databases. So it's something that can be done.
But you will still have to figure out to avoid having a user being routed to that blue-green deployment or canary release, because otherwise you will impact your real user. Because obviously, at the end of the day, you're doing load testing on that node. So keep that in mind. Okay, so interested. How are you things handled by Akamas when the configuration change? That's interesting. How are things handled by Akamas when the configuration change, need the application to restart? Example, JVM options and so on. I think you already partially answered. Depending on technology, you need to probably restart, but there are a few technology where you don't need to restart.
Yeah, exactly. It's a trend that is improving. So lots and lots of technology are actually can be reconfigured on the fly. And for when you need to restart, you can integrate these into the workflow so that you don't have to do that manually.
There's questions more of, I think that someone wants to have a try. Is there an example project available for self-exploring the NeoLoad Akamas integration? So the integration is available directly in Akamas product. So I think you should definitely have a trial with Akamas if you want to play and have a look by yourself. That's would be my answer, but Stefano, is it correct?
Yeah. Just get in touch with us, and we'll have demo studies like to showcase integration that can be used as a quick start to explore the approach.
What would be the differences between using NeoLoad and JMeter? Because you showed JMeter.
Okay, sure. So of course, one of the biggest differences is that, of course, we have all the telemetry that is being gathered by the NeoLoad, which is a huge plus of the tool. So JMeter out of the box doesn't allow any any metric to be monitored on the system, which as we share is a very helpful best practice. And once we have that, we can also make more powerful analysis on the Akamas side, and also use this kind of metric for as a goal for the optimization. So this is mainly one of the biggest advantages from our perspective. But then of course we know that we have lots of other kind of benefits for NeoLoad in terms of scripting, etc.
So basically, you won't be able to define your constraints based on error rates, response times, because Akamas is not able to collect them from a JMeter standpoint.
Yeah, there are ways to, for example, by using Prometheus, so other open source tool also to integrate metrics for the load test, also for JMeters. Yes.
Okay. What type of technology Akamas is able to support? Is there a specific optimization package for technologies, or?
Yeah, we built the platform to be generic, so we cover pretty much the whole stack, and we are always working to actually improve them. So we support cloud and infrastructure, so cloud providers, operating system like Linux. We support the databases, lots of NoSQL databases have pretty significant impact on the performance optimization like this. By the way, MongoDB, Cassandra, etc., and also Postgres and MySQL on the relational databases. Java and containers are another huge area of focus for us, and also big data platform, which is a kind of little bit different because it's a more like a batch kind of style of processing, but also we find very interesting results also there.
How long would it take for Akamas to optimize the system?
So that's a great question. It's I guess the number one question that we get. It's actually depending on the number of parameters that you ask Akamas to optimize. So of course, the machine learning, we designed our AI to be as smart as possible to understand with as few as possible experiments where are the biggest regions of the optimization space where you can get the benefits. Usually we get very interesting benefits already in a matter of 12 hours or during the first day.
Okay, so I'm looking at the time, so I think we already answered most of them. So if you have still questions, please reach out to us. We will be an honor a pleasure to answer them. Thanks for your time, because I see it's that we were longer than expected, but I think the content was great and interesting. So I hope that you enjoyed it as much as we do. So thanks for being here. Thanks, Stefano, for this nice presentation. And
thanks a lot. Thanks for joining us.
Great, thanks. See you soon. Stay home, stay safe. Enjoy the summer now, I think. And see you soon. Bye.
Thank you, everybody.